Okay, this is just a quick overview of problem number 24 in Giancoli's 6th edition. I basically worked out problem 24 on the board. Now what I notice when I go to the solution manual is that there's a equation inside the text. For example, number 3(8), and what they give you is the range, equation called the level horizontal range. And what that does is, using a trig identity, it's kind of a simplified formula that if you know you can find the range if you're given the initial velocity squared times sine 2 times the theta over g. So that's a really clean, easy equation to use for this problem, and that would just give you a quick little simple solution. If you didn't have that formula and you just had the canonical motion equations, the solution is doable, but it's a lot messier, and I actually powered through those on the board. It took about 20 minutes to solve, and I went ahead and made a YouTube video on how to solve the problem. So I'm going to go ahead and post this, and I just kind of want to give this little preface so you know that there is an easier solution. Again, just go to example 3(8) in the textbook, and you'll see R equals V sub naught squared times sine of 2 theta over the acceleration of gravity, and that'll give you the range. It's a very easy equation to use for the problem, and that equation can be used for a couple other problems too in the problem set. Anyways, with that, we'll go ahead and get started. Now what we're going to do is solve a problem where you have a long jumper jumping at 28 degrees. We're asked to find the initial velocity. Okay, so we don't know the magnitude of the initial velocity, so let's write this here. This is unknown. We don't know the time it takes, so t, but we do know delta x. It's 7.8 meters. We know delta y equals 0 because from the beginning to the end there's no overall change of displacement. Okay. Now, what we need to do is break it up into the x and y components. So let's do the y first. The first equation is delta y equals v y, the initial v sub y, times t plus 1/2 times the acceleration due to gravity squared. Then our second equation, v sub y squared equals v y sub 0 squared plus 2 times the acceleration y0 minus y1. Now this equation is not very useful to us because since y sub 0 and y are equal, this whole thing goes to 0, and we already know that the initial velocity here is going to equal the final velocity over here. So this is not a very useful equation for solving this problem. Then the last one is velocity in the y direction equals acceleration times time. Let's add this other component here, the initial velocity in the y direction plus acceleration times time. So we have basically we're going to need to talk about the x direction, so we need to also write those down. Delta x, can I still see the board where I'm writing here? Delta x equals the velocity in the x direction times time plus 1/2 times the acceleration due to gravity squared. But the thing is, there's no acceleration due to gravity in the x-axis, so that goes to 0. Okay, this equation, velocity in the x direction equals the initial velocity in the x direction plus 2 times acceleration of x sub x minus x sub 0. Since there's no acceleration, this goes to 0. So this equation is not very useful either. So the very last equation, velocity in the x equals the initial velocity in the x plus acceleration times time. There's no acceleration in the time. And this is kind of meaningless. We already know this. So the only thing that's left over in the x direction is this. So okay, let's count up the unknowns. We don't know this. We don't know this. We don't know time. Okay, so we got 1, 2, 3 unknowns. And this equation, that's that unknown, that's that. Let's see, the initial, we don't know this. This is also the third unknown. V sub y, these two are going to be equal to each other. So you can bring that out. Okay. Now let's see. We need to include the components. So let's go ahead, and, since this is just a component of the initial velocity vector, and this is just a component, we could substitute these out and get rid of, we'll just have 2 unknowns. Okay, so v sub x equals velocity. Sounds like it's raining back there. Cosine of 28 degrees. And v sub y equals the magnitude of the velocity vector times sine of 28 degrees. And since it's only at 28 degrees when it initially takes off, this is only true for this case right when it takes off. But that's fine, because that's what we're trying to figure out. So this can get plugged into this one. And this can get plugged in right here. Right, guys?
Correct.
Yeah?
Yeah, right.
You guys are crack up. So let's get rid of this. Make some room here. Now we're getting closer. Okay, we now have 2 unknowns. Time is an unknown, and this is an unknown. Right? Because we have this getting replaced by this. So what I want you to see is that this is an unknown and time is an unknown. So we have 2 equations, this equation and this equation, and 2 unknowns. So we can solve it now. Okay. I'm going to move this equation over here. So we have room. V sub y equals Vy sub naught plus AT so this equals 0. Delta y equals 0. Times t plus 1/2 a t squared, and then this equation would be 7.8 meters equals v sub 0 cosine of 28 degrees times time. Okay, since that's 0, I can pull this thing over here, or put the equal sign in the middle and make this negative. And I can also divide out the t. So now this is not t squared anymore, it's just t. Let's see. Okay, then I can solve for this and plug it into here. This is a messy problem. I want to replace these with the actual decimal number because this is going to get messy if I don't. Let's see. There was a calculator over here, right? There it is. Cosine 28 degrees. Cosine. This is 0.88. 0.88 times time. Let's see. I can flip this up, divide these two, and go ahead and get times 7, 8 equals. I can flip this up to the top, and this becomes 8.8 meters over time. Okay, so that's simplified. I get rid of that. Now I'm going to convert this into a decimal. You guys are crazy. Who's doing good? Them?
No, you.
Okay, that becomes 0.46. Let's see. This is negative. Negative 1/2 a t squared. Get rid of that negative there. Make this 0.47. Times 0.47. I can divide this over here to this side. That's right, I eliminated one of these t's, right? So 0.47. So minus 1/2 a t over 0.47. Acceleration is 9.8. But half of 9.8 is 4.6. Oh, 4.9, sorry. And then divide that by 0.47. Equals 10.4. 10.4 t. Then need to substitute. Of Go ahead and set these equal to each other. And I see this part of the board. So that means 10.4 t equals 8.8 over t. The acceleration is negative, so these two negatives cancel out. So that negative goes away. So time squared equals 8.8 divided by 10.4. Okay. All right, let's do that. You guys having fun?
No.
8 divided by 10.4 equals t squared equals 0.85. Take the square root of that. I get time equals 0.92 seconds. So that's the time. Now we know time. Let's see, where can we plug it back in to get our... We can use this equation. Okay. Now, I've just erased this just to clear up room. You didn't need these equations more now that I have the time. So this is, again, this is 0. So I could back substitute time to find these velocities. This is going to be negative. So if I bring this over, it cancels the negative for the 9.8 that goes in here. So let's put Vy sub 0 times time equals 1/2 AT squared. Now I could divide out the t again, like I did last time, and get that. That's scary. We've got all nationalities back there. Okay, so we have time, which is 0.92 seconds. Let's go ahead and substitute these in. 9.8 meters per second squared times 0.92 meters. 92 seconds equals. All right. 0.5 times 9.8 times 0.92 equals. So the answer for Vy sub 0 is 4.5 meters per second. Okay, so we're almost there. Now I need to back substitute this in. Let's see. This equals 7.8 meters. I need to go ahead and rearrange this equation to solve for the initial and the v sub x. So it's delta x, which is 7.8 meters, divided by 0.92 seconds. So to clear my calculator here, I have 7.8 divided by 0.92. So Vx sub 0 equals 8.5 meters per second. So now I have to, all I have to do is substitute back in and find, use the Pythagorean theorem to find this right here. So let's go ahead and take away our 0. So if I square that, let me write Pythagorean theorem. Make some Still see that? Yeah, I can still see that part. So this equals the square root of Vy. Let's do x here. X sub 0 squared plus Vy sub 0 squared. So let's go ahead and calculate that out. Let's see, exponent. Where's it at here? Let's square this. 8.5. Clear. 8.5. 72.25 equals 20. That squared is 20.25 plus 72.25 equals 92.5 on the square root. The total magnitude, the answer right here is 9.6 meters per second. All right. That's it. Yeah, you want to make a closing message?
Thank you for visiting Mr. Mendez's virtual classroom. If you ever get stuck on homework, please visit anytime. I'll be YouTube sensation. Just watch. Okay, consider that. My part.
Yeah, hold on.